At first, the conversation around 3i Atlas was simple. A fast interstellar visitor, a rare object from another star system, a scientific anomaly, but still a natural one. That story is starting to crack. Because with every new update, every new imaging pass, every fresh data set, the wording from scientists is slowly changing. They're no longer talking about pure chance. They're no longer speaking just in terms of unusual. They're now circling a word they use to avoid completely. Engineered. Not confirmed, not accused, not declared. But no longer impossible either. And that shift didn't happen because of one chaotic YouTube theory or a grainy telescope frame. It happened because of repeated independent observations, all pointing in a direction that astrophysics didn't originally expect. A direction towards structure. The first signs weren't dramatic. They were subtle, almost boring if you didn't know what you were looking for. Slight variations in brightness symmetry, non-random light absorption patterns. Reflection angles that didn't match known ice dust behaviors. But when these signals showed up consistently across separate observatories, different telescopes, different countries, different teams, the pattern stopped looking like coincidence and started looking like design. Still hypothetical, still cautious, but undeniably intentional looking. One of the most interesting updates comes from spectral reflectivity analysis, a method where astronomers analyze how light bounces off an object at different wavelengths to determine its composition and surface structure. Normally, comets behave like dirty snowballs. They absorb a certain range of light, reflect another, scatter the rest randomly due to irregular surfaces. 3i Atlas didn't behave like that. Instead, it showed directional reflectivity, meaning certain regions of the object reflect light differently depending on angle, not random orientation. That usually suggests surface segmentation, layering, or structural surfaces rather than chaotic ice dust clusters. And in engineering, directional reflectivity doesn't happen by accident very often. This isn't proof, but it's definitely suspicious geometry. Even more interesting, the polarization behavior. When light from distant objects passes through space and reflects from surfaces, it becomes polarized in predictable ways. Astronomers use this to figure out if a surface is smooth, rough, porous, or metallic. 3i Atlas showed polarized reflection patterns inconsistent with known celestial bodies. Not fully metallic, not fully rocky, not fully icy, something in between, something mixed, something layered. And that's where the word engineered keeps creeping back in. Because engineered objects often aren't made of just one thing. They're composites, they're processes, they're built from purposes. Another major update came from its thermal signature. Normally, when an object this size approaches the inner solar system, parts of it heat unevenly depending on surface composition and rotation. Hot spots form randomly. 3i Atlas didn't show random thermal distribution. Instead, its heat signature appeared almost regulated. Certain areas warmed faster. Others remained cool, unexpectedly. Some regions released energy in slow, controlled pulses. Not violent outgassing, not chaotic thermal cracking, but patterned thermal behavior. That isn't how natural junk behaves. That's how insulated structures behave. Now, before we go too far, nobody credible is saying it's a functioning machine. No thrusters, no signals, no propulsion activity. But the growing evidence suggests this might not be just a broken rock either. It might be a relic, a fragment, a piece of something much older. Something that once had a purpose, but now drifts, silent, through interstellar space. Not a spaceship, more like debris, technological debris, which in a way is even more eerie. Because civilizations leave debris long after they're gone. And if that's what this is, we're not watching intelligence. We're watching its fossil. The reason this idea is gaining more traction in private scientific circles is because of one uncomfortable fact. Random nature almost never creates layered symmetry repeatedly across different observational methods. It creates mess. It erodes. It breaks. but it doesn't maintain internal consistency after millions or billions of years of cosmic radiation, collisions, and thermal shock. 3I Atlas has. It's maintaining coherence, it's maintaining alignment, and more disturbingly, it seems to have structural integrity beyond what interstellar travel should allow. Most naturally ejected objects don't survive long journeys intact between star systems. Micrometeorite bombardment, cosmic radiation spalling, temperature cycling near different stars. They degrade. They fragment. 3I Atlas didn't. And that brings another layer of scientific discomfort. Because if this object truly originated outside our system, possibly light years away, then its preservation suggests either an extraordinarily rare natural composition or intentional structural design meant to withstand extreme travel. Either possibility is incredible, but only one changes our understanding of the universe permanently. The next update came from rotational motion analysis. Scientists track how an object spins by observing repeated brightness fluctuations as light reflects off it. Most comets have chaotic spin patterns. 3I Atlas doesn't. It rotates with surprising stability. Not simple, not perfectly symmetrical, but stable, even when solar radiation is disturbing its surface. That tells researchers one thing: it has internal mass distribution, unlike loose rubble pile objects. It's not just clumped debris held together by weak gravity. It is organized internal density. That's not normal, at least not for objects that have traveled that far. And still, official public statements remain cautious. Terms like unusual morphology, complex internal layering, atypical reflectance behavior, structural anomalies, they carefully avoid the word engineered. But internally, scientists are debating it seriously, not as a conclusion, but as a possibility they can't mentally eliminate anymore. Because this isn't just about one weird visual, it's a convergence of data, visual patterns, spectral behavior, thermal stability, rotation coherence, structural persistence, each one strange on its own, but together, they form a picture that refuses to stay neatly inside the natural comet box. And that's why this update is different. This isn't speculation coming from outside science. This is discomfort growing inside it. Not because they want it to be artificial, but because the data keeps refusing to behave naturally. Scientists don't fear alien objects. They fear unexplainable data, because unexplained data means broken models, and broken models mean scientific revolutions. Right now they're gathering even more. Deep infrared scans, sub-millimeter wave analysis, high-frame composite imaging, magnetosphere interaction studies. They want to know if there are internal cavities, density discontinuities, energy absorption patterns that suggest layering or internal structure, because if those are confirmed, then 3I Atlas becomes something else entirely, not a visitor anymore, but a discovery. The kind of discovery that forces humanity to accept a new reality. Not that life exists elsewhere, that technology might have existed elsewhere, long before us, and that its remains are still drifting through the dark. Right now, we're not looking at an alien threat. We're looking at a potential cosmic artifact, not active, not aware, not trying to communicate, just silently passing through our solar system on a trajectory set long before our species even existed. A piece of another story, another timeline, another intelligence. And the question scientists are quietly asking now isn't, is this artificial? It's, what if it is? And we're just now capable of noticing. Because if this one passed close enough to detect, how many more have passed when we didn't have the instruments? How many technological relics drift through the galaxy unnoticed? How many silent monuments to extinct civilizations surround us without us ever knowing? 3I Atlas might not be the first. It might simply be the first we had the eyes to recognize as strange. And that's what makes this update terrifying and beautiful at the same time. Not the idea that we're not alone, but the idea that others may have come and gone long before us and left things behind. Things are still traveling, waiting to be seen.